Again, these lectures cover the selection statements using logical operators. We normally use the logical operators to combine two or more conditions. So our main objective is to combine conditions using the logical operators, the AND operator, or and not operators. Also, we are going to use the selection statement with combined conditions in a program example. So these are the logical operators. We have the not, and or. So not is a logical negation, which means if we said not true means it's false, and not false means it's true. So not operator is to negate. And we have the and operator is called the logical conjunctions. So if we have two or more conditions and we are using and operator, all the conditions have to be true in order to perform any task. Also, the or is called the logical disjunction. In the logical, if we have two or more conditions and we are using logical operator, only one condition have to be true, then the task will be performed. So let's see the truth table for the not operator. So as we said, if our input P is true, then not P will be false. If our P is false, then not P will be true. So normally the not operator, we use the term unary operator. A unary operator means it takes only one operand. So we have a P, not P. If P is true, it will be false. If it's false, it will be true. So example given here, assuming we have 24, we assign 24 to age variable. And also we assign female or F to gender. Now we say not age greater than 18 is false because the age is greater than 18 is true. So again, let's assume this is true. So if age is 24, not age greater than 18 means age is less than or equal to 18. So the answer will be false because age is 24. Now, not gender M, male, that means if it's not male, it's female. And our gender is female, so it's true. So not true is false, not false is true. The next is the AND operator. As we said earlier, the AND operator, if we have any amount of conditions and one of them is false, then the final output will be false. Every condition have to be true in order to have true output. So if I have, for example, 6 conditions and all the 6 conditions, 5 of them are true, but 1 is false, the output will be false. All the 6 have to be true for the output to be true. So here we assuming we have 2 conditions, P1 and P2. If P1 condition is false and P2 condition is false, then P1 and P2 will be false. If P1 condition is false and P2 condition is true, then P1 and P2 also will be false. And if P1 condition is false, but P2 is true, P1 and P2 still will be false. Here, the condition will be true only if all the conditions are true. So if P1 is true, P2 is true, then P1 and P2 is true. Let's use the example here again. We have age is 24, weight is 140. And now we said that if age is greater than 18, which is true because age is 24, greater than 80, and the weight is greater than or equal to 140, and it's false because what? The weight is greater than 140. It cannot be equal to 140. So since one condition is false, everything is false. The outcome will be false. Now let's see the next one. Age is greater than 18, which is true. And then weight is less than or equal to 140. Yeah, that's true. So because both are true, the output will be true. Now let's look at the OR. As we said OR earlier, the OR operator, if only one condition is true, then the output is true. Even if we have hundreds of conditions and only one is true, the output will be true. So here we have P1 is false, P2 is false, then we get false. So the only time we are going to get false with OR operator is if only all the conditions are false. So now we can see we have false and true, the output is true. True, false, the output is true. True, true, we still get true output. So let's use the same example here. Age is 24 again, weight is 140. This time we said if age is greater than 34 or weight is greater than or equal to 150, it will be false because both conditions are false. Age is 24, it's not greater than 34. Weight is 140, it's not greater than 150. Now, here, if we say age is greater than 14, okay, that is true. So I will not even check the weight since age is true. If one of them, the condition is true, then output will be true also. So let's see how this program is used. And this program will use the logical operators. So we have a question here, a program here. First, we ask the user to enter an input. The input will be int. Then we said that if the number the user enter modulus 2 equal to 0, and also the number the user enter modulus 3 equal to 0, it means the number is divisible by 2 and 3. So for example, if the user enters 6, 6 modulus 2 is 0. 6 modulus 3 is 0. So the output will be printed that 6 is divisible by 2 and also 3. Next, again, what we are learning here is how to use the logical operator AND. So AND operator means both conditions on the left and the right must be true in order for us to print the statement. In this case, if I enter 6, the statement will be printed because 6 modulus 2, the remainder is 0. If you divide 6 by 2, the remainder is 0. 6 modulus 3, if you divide 6 by 3, the remainder also is 0. Now, if I enter 9, 9 modulus 2 is not 0, it's false. So I will not even check, I will not check the second because AND operator, if one condition is false and you have hundreds of conditions and they are all true, still the output will be false. So let's look at the second one. The number modulus 2 equal to 0 or the number modulus 2 equal to 0. Here we have all. So now I'm going to use 9. 9 modulus 2 is false. 9 divided by 2, the remainder is not 0. But 9 modulus 3 is 0. 9 divided by 3, the remainder is 0. So in this case, 9 will be printed. So 9 is divisible by 2 or 3. So we can see the difference between AND and OR. With AND, all the conditions have to be true in order to execute our print command. And the second is OR operator. So only one of them have to be true. Now, if both is true too, that's fine. We're still going to execute. Now, next we said if number modulus 2 is equal to 0 or number modulus 3 is equal to 0 and not number modulus 2 equal to 0 and number modulus 3 equal to 0. Here we need to be careful because we have and, or, and not. So we have to use the order of precedency. The order of precedency is that not will be executed first, then and, then or. So in this case, we have parentheses. So this is good. Parentheses always first. So number modulus 2, let's say we enter 6. 6 modulus 2 is true. So here we know we have true here since one of them is true already, it's or. Then here we have not first because and not. So which means we are going to execute this first. Let's say we are using the same 6. 6 modulus 2 is equal to 0 and 6. So the answer here will be true since both are true, is n. So 6 modulus 2 is equal to 0 is true. Number modulus 3 equal to 0 is true. So that means here also we have true. But not true will be changed to false because we have not. So when we change it to false, Now, true and false will give us false. So if I enter 6, this will not print out. So again, that's the whole concept here. So here we say the number we have to enter should be divisible by 2 or 3, but not both. But you see, when I enter 6, 6 is divisible by 2 and also is divisible by 3. So that will make this condition true. Now, when you make this condition true, not change it to false. Then when we have false and true, our answer will be false. Now let's try 9 before we end. So 9 modulus 2 equal to 0. And this will still give us true because it's all operator. So 9 modulus 3 is true. False, true, so we get true. Then we come here. 9 modulus 2 is false. So that means we have true and false. But false here will change to true. So we are going to get not false, which is true. And then we have true and true. So this will be executed. And that's right. 9 is divisible by 2 or 3. But in this case, it's divisible by 3. And it's not divisible by both, but not both. So it's not divisible by 2. So again, that's the whole concept of how to use the logical operators. So our next program here, and this program first prompts the user to enter a year as an int value. Then need to check if the year is a leap year. Normally, a leap year is a year is a leap year if it is divisible by 4, but not by 100, or is divisible by only 400. So we have the condition here. A leap year means the year is divisible by 4, which means year modulus 4 equal to 0, and year modulus 100 not equal to 0, because we say divisible by 4 but not by 100. But also it can be divisible by 400. So this is what we are learning here. Let's go back. So a leap year means, based on the question condition, year modulus 4 equal to 0, which means a leap year is divisible by 4. By year modulus 2 not equal to 0, it's not divisible. So if this is true, then it's a leap year. Or if this is false and the year is modulus 400 is equal to 0, it's true, then it's still a leap year. So let's look at the program. So in this program, the user is going to enter the year as int. Then when he enter it, we are going to check if it's a leap year. So the year that the user enter, we say if we divide the year by 4, the remainder should be 0. And also, if we divide the year by 100, the remainder shouldn't be 0, not equal to 0. If this is true, then it's a leap year. Or if this is false, but the year modulus 400 is equal to 0 is true, then it's still a leap year. Remember, we are using the or. In Python, we use this slash if we have a long expression and we want to continue on the next line. So we use the slash here. So here we're going to display our result if it's a leap year or it's not a leap year. Depends on the condition we have here. And this condition, you can see that the answer here will be either true or false. So we assign to this variable and we print the content of the variable. Let's try the animation of it. So here they say we should enter the year. I'm going to enter 2000. Then next they say what will be a leap year after the statement executed. Well, if I divide 2000 by 400, the remainder will be 0. So I'm going to say true. See. So we say you are correct. So its leap year will be true, and we are going to print it. So here, 2000 is a leap year, and that is true. So we also have what we call the conditional expressions. For example, we have the two-way saying that if S is greater than 0, we assign 1 to Y, else we assign -1 to Y, which means if the condition is false, Y answer will be -1. Now we can write this in this form also. This is called conditional expression. Here we have the condition saying that if S is greater than 0, we assign 1 to Y, else we assign -1 to Y. So here we say the expression 1, if Boolean expression, else expression 2. So we have an expression, then we have the condition. If S is greater than 0, assign the 1 to Y. Else is false, we assign -1. And this is the concept again. If number modulus 2 equal to 0, print is even, else the number is odd. So here we are using the two-way if else. Now we can use the conditional statement saying that, okay, print number we enter is even if number modulus 2 equal to 0, else the first section we print is odd. The number is odd. So these two are the same. And we use the term conditional operator. So the operator precedency, we saw it. Normally we start with the plus, minus, exponential, not. All the way down we have the and or before the relational operators. So the operator precedency associative is very important, especially if we are combining many conditions together with different logical operators and relational operators. So here we said the expression in the parentheses is evaluated first, as we saw the previous example. In the parentheses, it doesn't matter whether it's a relational operator alone, whether it's a logical operator, and or always the parentheses evaluate first. Then the parentheses can be nested. If the parenthesis is nested, which means we have a parenthesis inside another parenthesis, then the inner parenthesis will be executed first, in which case the expression in the inner parenthesis is executed first. Now, when evaluating an expression without parentheses, then we need to consider the operator's precedence. Now, if operators with the same precedence are next to each other, then associative determine the order of operation. And again, all binary operators except assignment operators start from left associative. So here we are going to end the lectures. And again, I skipped one slide here. So this slide again is an example of the operator associativity. So for example, we have A minus B plus C minus C is equivalent to, since A minus B, inner one will execute first, then the plus will be next, then the last will be D minus D, using parentheses. And this is right associative for assignment operator. So left associative, it can be for addition, subtraction, etc. So again, thank you for your time, and we will see our next lectures will be on chapter 4, which will start with the Python built-in functions. So we're going to discuss, example, the string functions, that these are built-in functions, the math class, etc.